Okay, so we were looking at the integration by parts, and we typically chose the u to be the thing that differentiates to 0. And there are a couple of exceptions to this. And the first exception deals with natural logarithms. And so to kind of see this, I am going to do a comparison here for this first one. I'm going to compare the integral of the natural log of x divided by x with respect to x to the integral of x times the natural log of x with respect to x. And so if we go through the process, starting with the one on the left, we go ahead and try to do a basic rule, and there's no basic rule that has a natural log of x in it. So we then try to do a u substitution. And remember, with natural logs, you can do a u substitution allowing u to be that natural log of x, as long as you have the u prime associated with that, and the u prime associated with our natural log of x would simply be 1 over x. So if I go ahead and I rewrite my integral, maybe making it a little bit easier to look at, this is the same as the integral of 1 over x times the natural log of x with respect to x. And I can clearly see that this entire piece becomes my u prime, and this piece right here is a u to the first. And remember, when we look at what we're integrating, I'm looking at what I have in blue here. So when I integrate this, u to the first times u prime, I'm going to get a 1/2 u squared all plus c. So putting back in my u, this is going to give me 1/2 times my u, which was the natural log of x quantity squared, all plus c. And we saw that as we went through our last section. Well, let's go ahead and look at the one on the right and see how that one differs. Again, if I were to try to choose my u to be the natural log of x, I would still need the u prime of 1 over x, and that's not what I have here. I don't have a 1 over x, and there's no way to turn that x into a 1 over x, so that's not going to work. What we're going to have to do instead is to try an integration by parts. In the integration by parts, we typically pick the u to be the piece that differentiates to 0. But in the case of a natural log, if we have to perform an integration by parts, we cannot let u be the part that differentiates to 0. We have to let u be the entire natural log piece. So it is going to be the natural log of x. That means that our dv will be everything else, which is x dx. Now that we've defined these things, we can go ahead and get our du. Remember, by definition, u prime is du dx, and that's just the derivative of the natural log of x. The derivative of that thing looks like the following. You've got what you see on the bottom, which is x, and the derivative of that on top. Then multiplying both sides by du, I get that dx, I get that du will be equal to 1 over x dx. So I have two of the pieces that I need. The only other thing I'm going to need here is v, and by definition, v will be the integral of dv. So it's going to be the integral of x dx. When I integrate this, I'm going to get the 1/2 x squared. Remember, we don't need to worry about the plus c. We'll put that at the very end. Okay, so I went ahead and rewrote this at the top of my next page. I had to flip a page, so we should be in the same spot. And so remember, when we set this up so that we had u, and then the entire rest of this was dv. And by definition, the integral of u dv will be equal to uv minus the integral of v du. So in our case, we get then that the integral of x, natural log of x with respect to x, is going to be equal to, we're going to take our u and our v and multiply them together, and so we get 1/2 x squared natural log of x minus the integral of v times du, and that looks like, it looks like 1/2 x squared times 1 over x dx. Now let's clean up that back one so we can look at this a little bit better. That's going to give us 1/2 x squared natural log of x. I can bring out the negative 1/2, and notice you have an x squared on the top and an x on the bottom, so one of those will cancel with one of those, and it looks like we'll just be integrating x with respect to x. And so doing that final integration and putting in our plus c, we get that that integral is equal to 1/2 x squared natural log of x minus 1/2 times 1/2 x squared, all plus c, or 1/2 x squared natural log of x minus 1/4 x squared plus c. Now, at this point, we may be asking ourselves, why did we make the choice we did? Why didn't, and I'm looking back here to my problem up at the top, when I looked at this problem of the integral of x, natural log of x, why didn't I just pick u to be the x? Why didn't I just do it that way? Well, here's the reason behind it. Let me grab another page here to show you. We started out with the integral. This is an explanation. We start out with the integral of x times the natural log of x dx, and if we were to attempt a integration by parts the normal way, that is, we were to let u be the piece that differentiates to 0, then the dv would have been the natural log of x dx. Now from that u I can find my du, that's not a problem, but the problem here is, can I get a v? And the answer is no, because can I find the integral of the natural log of x with respect to x? And the answer to that is no. We don't have any rule that allows us to just integrate that. And so since we cannot perform that integration, we have to pick this the opposite way. Hence, our first exception is if we have a natural log and we do not have a u substitution, then we do not pick, we do an integration by parts, not picking the u to be the part that differentiates to 0. This will end our first example. I'm going to do another one, and we can look at in our next video.